Hey everyone, in this video we are going to understand one question based on the recursion. That is, we have to find the sum of first n natural numbers and we have to solve this problem using the recursion. Okay, so we have to write the recursive solution. So before starting, let me tell you, I have made a full playlist of the recursion which a beginner can understand, and also the person who are actually facing the problem in understanding the concept of the recursion, and they are facing the problem in how we can write or how we can think the recursive solution. They can also understand these videos. Okay, so you can find the link of these videos in the video description below in the recursion playlist. Okay, so do watch them. Now let's start with the video. So basically the question is, if user enter n equal to 3, then we have to find the sum of 1 plus 2 plus 3. Okay, that is 6, and we have to return 6. If n is 4, then we have to find the sum of 1 plus 2 plus 3 plus 4, that is 10. Okay, to find the sum of n natural number. Okay, so if I ask you what is the iterative way to write the solution for this question, so this is the iterative way. Let's say we have a function find sum which is taking the n as the parameter, okay, and it is returning the final sum, okay, as the answer. So basically I have taken the help of the for loop. You can make this program using any of the loop. Okay, so basically I have to generate this 1, 2 and 3, right? So I is helping me to generate 1, 2, 3, right? So for n equal to 3, this loop will be true for I equal to 1, I equal to 2 and I equal to 3. Okay, and this I will be added with the sum. Okay, so initially it will be like 1 will be added with the sum. Okay, and sum is initially 0, so 0 plus 1 is 1. Okay, next time 1 will be added, okay, with the new I will be 2, so 2 plus 1 will be 3. Okay, so this is my sum, and then next I will be 3, so 3, that is this I will be added with the previous sum 6. Okay, and then this loop will be false and sum will be 6, it will be returned. So I hope you know that how we can write the iterative code. Okay, so I'm not going to explain again more in detail for this iterative approach. In this video we are going to see the recursive solution, right? But if you know the iterative method, it is very easy to change this iterative code into the recursive solution. Okay, so basically the problem will be same in the recursive solution also. I have to generate somehow these numbers 1, 2, 3. Okay, so that I can add them. Okay, and addition is the repeated task that we are performing. Okay, so here that repeated task is done with the help of loop, but in the recursive solution that repeated task will be done with the help of function calls again and again, right? So let's see. So now before starting, let me tell you, even if n is 3 and somebody give a solution in the recursive approach that he is adding 3, then he is adding 2, then he is adding 1, then also the final sum will be 6. For n equal to 4 also, if I start adding 4, then 3, then 2, then 1, then also the sum will be 10. Okay, so I can add in any manner. Either I should start from n to 1, okay, or either I should start adding the numbers from 1 to n. Okay, both will give me the same answer. Okay, so basically in the previous videos we have discussed that how we can generate these numbers 1, 2, 3, n natural numbers in the ascending and descending order. So this was the code that was helping me to generate the numbers in ascending order, that is 1 to n, right? 1, 2, 3, 4 till n. And this was the code that was helping me to generate the number in the descending order from n to 1. Okay, so if n is 4, then it was generating 4, 3, 2, 1. Okay, so if you have not watched these videos, you can find the link of this video in the video description below. Please do watch them. Okay, and here in this code, as you can see, we have plus plus I. I can write I plus 1 also. The same way, here I have written minus minus n. I can write n minus 1 also. Now I will give you the three approaches or the three solutions for solving this question in the recursive manner. I will solve this question using this global variable. Second will be using the static variable, and third approach will be without any global and static variable. Okay, and all these approaches are very important. Okay, so watch the video till the end. Okay, so our first solution is writing the recursive program using the global variable. So I will actually tell you the need of the use of the global variable, that why do we actually need the global variable. Okay, so this is our attempt 1, okay, to write the recursive code, and accordingly I will move towards the use of the global variable, use of the static variable, and so on. Okay, so basically this is the program that we have done, okay, in the previous video, as I have told you that this was generating the number in the descending order. Like if we give n equal to 3, then it will print 3, 2 and 1. Okay, so basically this was the code that was printing the numbers in the descending order. Okay, so here, as I told you, the numbers were printed in the descending order. So this call was actually decrementing the value of the n. So initially n was 3, so it was like this will send the next call as print of 2, then print of 1, so on. Okay, and accordingly we are printing from here like 3, 2, 1. Okay, so what I will do in our recursive approach for finding the sum of the first n natural number, I will be making changes here. What I will be doing, as we have seen in the you can say iterative code, what we were doing, we were generating the number, okay, and then we were like adding inside the sum variable, right? That means we were adding the I, okay, inside the sum. Okay, so basically in this code, okay, in this code we have the n, okay, which is actually generating the number. So basically what I will do in my recursive approach, okay, I will be generating the number using the n, okay, in descending order 3 to 1, okay, and then I will be adding those 3, okay, inside sum, then 2 inside the previous sum, then 1 inside the previous sum. Okay, so this is the idea behind writing our first attempt. Okay, so let's see. So basically this is the find sum, okay, and this will be basically returning me the final sum after adding all the n integer natural number, right? Okay, so here you can see we have the recursive call. Now what I will do, basically if n equal to let's say 3, okay, basically I will decrement the number, okay, I will decrement the this n minus 1. So in the next call what will happen, here 2 will go, right? So basically you can see from here, if we have the fs is find sum, okay, I'm writing the short form. Basically main has called this fs of 3. So what I will do, I will come here, okay, then I will call fs2, okay, then I will call fs1, okay, and so on. So these are the 3, 2, 1, these are basically the numbers, okay, those are getting here. Now what I have to do with this n in each of these call, basically I have to find the sum, right? So basically I have to add these n, okay, inside some variable, let's say sum, okay. So I will do sum equal to sum plus n, okay. So this is the work that I am doing in each of the recursive call, okay. I am basically adding those 3, 2, 1, okay. The thing is, like we are decrementing this value of n from let's say 3, then 2, then 1. Now till what point I have to do this recursive call, okay, at last I have to, you can say we have to stop at some point of time, right? So basically here you can see we have to add, let's say if n equal to 3, then we have to add 3, then we have to add 2, we have to add 1, but we do not need to add 0, right? Basically when you can say the call will be made for 0 after this, okay, we do not have to like go on, and we do not have to call like fs of minus 1, we do not have to decrement this 0, like, so we have to return from here, like, okay. So after finding the, you can, or you can, after calling this fs of 0, okay, we have to basically return, okay, and we have to basically return the final sum, okay, the sum of, you can say for n equal to 3, the sum will be 6. So basically from here, okay, we have to return with the answer, that is 6, and we will finally return it to the main function. So basically we will come from here, okay, fs of 3, then we will encounter some base condition, okay. So base condition will be simply like when this n, okay, this is n, it will reduce to, it will change to 0, okay, then I will simply say return, okay. Now the thing is what I should return, okay, basically what I will return. So basically there are many ways to return the values, okay, but let's say for this point of time what I will be doing, I will be just returning 0. We'll see that how this 0 is helping us, okay, and other values also we can send, okay. You will be able to know it after the end of this video, okay. This sum variable I should you can say declare somewhere, okay. Let's say as a novice person, as I am attempting this question, let's say for the first time, okay, as a beginner, what I will do, I will declare a variable sum, okay. Let's say in the iterative code what we are doing, we are declaring this variable with initial value as 0. So let's say I took this in sum equal to 0, okay. Now let's see will this code work and it will give us the desired result or not. So let's say from the main function we got n equal to 3. So here sum equal to 0, okay, that means sum will be 0, okay. Now if n equal to 0, we'll check no, so we will add this you can say 3 with the sum, okay. So sum will become 0 plus 3, it will be 3. Okay, now after this I am calling this find sum n minus 1. Now after this call we have the return sum also. So you have to like see very carefully that return sum. Okay, return sum, this line is also present, but this line will be executed when we will go in the, you can say, backward journey. Okay, when we will be returning from here, then we will encounter this return sum. Okay, so for the time being sum is 3. Okay, now from here 2 will be passed, 3 minus 1. Okay, 2 will be passed. Now we have come here, fs of 2, again sum is 0. So this sum is a local variable for each of the call. Now n equal to 0, no, so sum plus 2. So previous sum was, you can say, 3. But the question is, here we have declared this sum again. So inside this call, this sum is a new sum with the initial value as 0. So basically here again 0 plus 2 will happen. Okay, 0 plus n, that is 2. Okay, so this 0 is this new variable sum. Okay, and this is the main problem in this code. Okay, we'll see. This n minus 1 will reduces to 1. So 1 will come here, and now 1 equal to 0. No. And before that sum is equal to 0 again in this call. Okay, we have encountered this fs of 1. Okay, sum is 0, 1 is not equal to 0, so 0 plus 1. Okay, 0 plus 1, 1, right? And then 1 minus 1, 0. So this is the last call, and again sum will be 0, but because n has changed to 0, so we'll return. So from here we will return with 0. We will not come here, right? And we will not come here, right? So 0 will be returned. Now the question is, this 0 is returned, but it will be returned where? Because we have come with 0 here. Okay, we have come here, so we will go back again, right here. Okay, so here 0 will be coming, right? So basically here we have come, okay, in this function call. Okay, so you can say 0 will come here, and then here we have the return sum. So basically here return sum. Now sum is this sum, and this sum was 1. So 1 will be returned. Okay, and then again in each of the call, as I told you, there was return sum. So here return sum, sum is like this one, not this sum. Okay, sum is this sum, so this 2 will be returned. Now again this will say return sum, so this will say return my sum. My sum is 3. Okay, that is the sum of the fs3 was 3, so 3 will be returned. So finally this 3 will be returned. Okay, not the previous. And again this answer is wrong. Why? Because we are not adding these 3, 2, 1 to the previous sum. This was okay, but 2 should be added with 3, and 1 should be added with the sum of 3 and 2, right? But here this is not happening, because sum is again and again inside with the, you can say, 0 value. So basically this sum is the problem. Again and again we are coming, and we are again and again making the sum as 0. So there are many ways to solve this problem actually. Okay, one is using the global variable, another is using the static variable. Okay, before this let me run this program and see in the ID that this will give us the wrong answer. So here is the code. Okay, so I have compiled this program, so let me run the value of the n as, let's say, 3. Okay, here you can say final sum is 3, and basically if you give the value of n equal to 4 now, then 4 will come actually. Okay, that is the, you can say, 0 plus 4 will happen, and only that will be returned. Okay, that means this answer is actually wrong. Basically if n equal to 4, then your answer should be 10, right? But this is wrong. Let me show you this code again with the help of the expanded function call and the stack, and then I will show you the correct solution using the global variable. So basically when find sum calls this method with 3, okay, so this find sum 3 was called, and this was 0 plus 3, right? And then again fs of 2 was called, so again sum was 0 plus 2. Okay, 0 plus 2, right? And then again it was called with 1. Okay, fs of 1 was called, again it was 0 plus 1, right? And then again it was called with 0 from here. Okay, so sum was 0, but n equal to 0, so 0 was returned as the sum. Okay, so this is the sum of the 0 natural number. Okay, sum of the 0 natural number is 0, so 0 was returned. Okay, then in each of the call you can see we have the return sum, right? So actually 0 was returned. Okay, here then it say, okay, I'm returning my sum. Okay, so its sum was 1. Okay, so basically 1 was returned, right? Now from here the sum was 2, right? So 2 was returned. Okay, so 2 was returned. Okay, now this say I'm returning my sum, so its sum was 3, so 3 was returned, right? So this sum is local. Now let's make the sum variable as global variable so that sum is having only one copy, and all these function fs3, fs2, fs1, fs0, they will use the single copy of the sum variable. So this is the solution using the global variable sum. So here this is the global sum, and the initial value of this global variable, as you know, is 0. Okay, so if you just write int sum also, then also this program will work fine. Okay, so basically how this program will work, so this sum variable, it will not be saved inside the stack, it will saved inside the data section of the main memory. Okay, this I have explained in the prerequisite video of the recursion. Okay, this sum is a global variable, so this sum will not be stored in any part of the stack. Okay, it will be stored outside stack in the data section part of the main memory for this application or for this program. Okay, so sum will be having 0. So now when this find sum with 3 value of n is called, so fs of 3 will be called, right? And then we'll come inside, we'll say okay, n is not reached to 0, so we'll add the value of the n with this sum. So basically n is currently 3, so 3 will be added with the sum. So 3 will be added with this sum. Okay, this sum is stored inside the data section part of the main memory. Okay, so 0 plus 3, it will be 3, right? Okay, so here you can see we are not saving sum here. Okay, now find sum of minus minus n, or you can say this is n minus 1. Okay, this is one and the same thing. Okay, for this example, so 2 will be called, find sum 2 will be called. So from here 2 is called, and 2 is not equal to 0, so we'll say 2 plus previous sum, right? So 2 is added with the previous sum, so sum is fetched from the, you can say, data section, that is 3 plus 2. Okay, so this will be 6, right? Okay, now find sum will be decremented and it will be reduced to 1. So this find sum 1 will be called, and again as is not equal to 0, so we'll be adding 1 with the previous sum. So previous sum was 6, so 6 plus 1, it will be 7. So now 2 will be added. Okay, and 3 plus 2 will be 5, right? And now n will be reduced and it will become 2. So sorry, it will become 1. Okay, from 2 to 1. So find sum 1 will be called, and n is not equal to 0, right? So this 1 will be added with this sum, that is 5 plus this 1, it will become 6. Okay, and now sum will be changed to 0. Sorry, this n will be changed to 0, and find sum 0 will be called. And now n is 0, so we will be returning this sum, that is 0. 0 is the final answer. Okay, after n is reached to 0. Now what will happen? This 0 will be returned to the caller. Okay, here, right? Now the next statement is return sum. So what value of the sum will be returned? So basically here you can see from here 0 was returned, right? And we came here. Now this call is saying return sum. So this call will be actually pointing to this sum. Okay, this sum, because there is only one sum, this do not have the local sum, right? So sum equal to 6, it will be returned. So 6 will be returned. So inside the find sum 2, 6 is returned. Okay, now it is again saying return sum, so it is actually pointing to the global variable sum. Okay, so again this 6 will be returned. Okay, so 6 will be returned to the find sum 3 method. Okay, 6 will be returned. Now it is also saying return sum, that means the global variable sum should be returned, and global sum is actually 6. So from here 6 will be returned to the main function, okay, and 6 will be printed as the output. Okay, so this is the idea behind using the global variable sum. Okay, here you can see I have now used the global variable sum. Okay, so now let me run this program. Okay, now if I enter, let's say 4, so here you can see sum is now 10. Okay, now let's run this program again, and let me give the value of the n as 3. So sum is 6. Okay, so this is correctly working. Now we can do this program using the static variable also. Okay, as the global variable is saved in the data section part, sum, or you can say static variable sum, it will also be saved inside the data section part, and all the function calls, they will be actually pointing to that static variable sum which is present inside the data section part. Okay, so that static variable will be treated as the global sum. Okay, so you can use the static int sum also, and that static int sum you can use here only. Okay, here only. So actually this is the way. Okay, so actually this is the way. Okay, static int sum equal to 0. Even if you just write static int sum, that will also be good. Okay, because initial value or the default value of the static variable is actually 0. Okay, so this sum is also you can treat as the global variable sum. but there is a difference between the global variable and the static variable other than their storage. Okay, but we are not discussing that thing here. Okay, we will discuss in some of the other video of the storage class. Okay, but you can treat here as this static variable as the global variable for the time being. So whenever there is a choice between the global variable and the static variable and both are giving you the same answer, just keep in mind that you should use the static variable. Okay, so this program will also work the same way as we were doing with the global variable. So here you can see I have used the static variable. Okay, and let me even erase this equal to 0 also. Then also you can see, let's say if I give the 5, okay, as the value of n, so the sum of the first 5 natural number is actually 15. Okay, 1 plus 2 plus 3 plus 4 plus 5, 15. So I'm getting this side, and so I'm getting the correct answer. Okay, so you can just check for the another value of the n also, it will be working correctly. Okay, now let's see the last approach without using any static and global variable. So basically if I want to find the sum of the first 3 natural number, okay, then I will say, let's say I have the solution of the first 2 natural number. Okay, that is I have the sum of the first 2 natural number. Okay, now to find the sum of the first 2 natural number, I will take the help of the first 1 natural number. Okay, find sum of the 1 natural number. Okay, so in this way I will be breaking my bigger problem into the smaller problem. Okay, and how it will be able to help my you can say finding the sum, and how it will be helping us to find the sum. So basically I will be saying, okay, when you are calling fs of 3, so this is basically add 3 with the answer of the first 2 natural numbers sum. Okay, so find sum 2 is basically like 2 plus 1. Okay, and if I have the sum of the 2 plus 1, then I can just add 3 and I can get the answer of the fs3. Now to find the sum of the first 2 natural number, what I need, this will be equal to 2 plus 1, and 1 will be given by fs of 1, the sum of the 1 natural number. Now fs of 1 is sum of 1 natural number, right? So I can also reduce it further and I can say the sum of the 1 natural number is like 1 plus 0, and 0 will be given by fs of 0. fs of 0 means find the sum of 0 natural number, and you know 0 natural number means you are not adding anything. So basically this will be base condition or the stopping condition. After this I will just return 0. fs of 0 will return 0. Okay, so what will happen, I am actually calling, okay, in this way. Okay, that is 3 plus something, 2 plus something, 1 plus something, and after this I am just saying stop, just return this 0. This 0 is the sum of the 0 natural number, right? So basically after this I will say just go and return 0. So after this I will just say okay, 0 is returned. Now I will say fs of 1 will be 1 plus 0, it will be 1, right? So 1 will be returned here. Okay, okay, so fs of 1 gave me the sum of 1 natural number, that is 1 plus 0, that is 1. Now this 1 will be added with 2 so that I can get the answer of the first 2 natural number. 2 plus 1, that is 3. Okay, so 3 is the answer for fs of 2. So fs of 2 will be replaced with 3, right? Now this 3, which is the sum of 2 plus 1, it will be added with this 3 so that I can get 3 plus 3, that is 6. And this is the sum of the first 3 natural number, 3 plus this 3, and this 3 is basically this 2 plus 1, and this 1 is basically 1 plus 0, and this 0 was the stopping condition. Okay, so in this way I am getting the answer in the return journey. Okay, in this journey I am actually breaking down my problem, and in this journey I am actually adding my answer and I am building my answer. Okay, so basically I will not use any sum variable basically. Okay, so let's see how we can write the solution. So basically this is the solution. When n reaches 0, I will return 0, otherwise I will do this function call. Okay, n is 3, let's say, from the main function, fs of 3 will be called, and n is not equal to 0. Okay, so I will say 3. Okay, you just add this 3 with the fs of 2, right? fs of 2, right? So basically fs of 2 will be called. Okay, from here n is getting decremented, right? Now we call the fs of 2, so again this is not true, so we'll come here. Okay, now I will add the natural number 2 with the sum of the first natural number sum, that is fs of 1. That means fs of 1 will be called, right? fs of 1 will be called. So here n is 1. Again 1 is not equal to 0. So I will say, okay, just add 1 plus fs of 1 minus 1 is 0. Right? Now from here 0 will be called. Okay. So here 0 will be called and 0 is equal to 0. So return 0. That means fs of 0 was called, but from here 0 was returned. And 0 will be returned where? 0 will be returned here only. Okay. It will replace this whole function call. 0 will be returned here. So now this addition can happen because I need a constant value here, right? So now this previous n, okay, this 1 plus 0, 1 plus 0 is 1, right? And this will be returned, okay? So return 1, okay? So fs of 1 is returning actually 1, the sum of the one natural number. Now this 1 will be returned here, right? So this whole answer 1 will be returned here, okay, in place of this function call. Now this 1 will be added with this 2, okay, 2 plus 1 3, 2 plus 1 3, and this will be returned, okay. So 3 will be returned from here. So fs of 2 is returning 3, right? So 3 is returned, okay. So now 3 is returned here, okay, and it will replace this. So 3 plus this n value, that is 3. So 3 plus 3, it is 6, right? So 6 is returned to the main function because this function was called from the main. So 3 plus 3, 6, and 6 was called from the main function. So 6 is given to the main function, right? So here we have not used any global variable, any static variable, right? We have on the way, okay, we are building the answer. So this is one of the another better way, okay, to write the recursive solution, okay. So if we want to find this time complexity of this recursive code, then what will be the time complexity? So basically, to find the time complexity, we should know how many times this function call is made. So basically, when n is 3, we have called 1, 2, 3, and 4 times, right? 4 times function call has been made. Okay, that means n plus 1 times function call will be made for general n, right? And each of the function call, we are doing this one. Okay, in each of the function call, we are doing this simple comparison, and this simple comparison will take how much time? It will take O1 time, right? So basically we are saying okay, 3 plus something. So basically in each of the function call, we are doing comparison, 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 okay, comparison. And in the return journey, we are adding also. So addition of two numbers, 1 plus something, okay, it will take unit amount of time, right? So again, the constant amount of time will be taken here. Again, constant amount of time will be taken here. Same constant amount of time will be taken here. Okay. So basically you can see in each of the function call, okay, in upward journey and in downward journey, basically 1 unit of time will be taken here and 1 unit of time will be taken here. 1 plus 1, 2. So 2 unit of time is actually being taken in each of the function call. Okay. And in last function call, only 1 unit of time was actually taken. Okay. So basically this 2 can be termed as simple constant time. Okay. So into some constant number. You can write simple order of 1 or simple 1. Okay. So this n plus 1 will be n plus 1 only, and the order will be n. Okay. So if you do not know how to find the time and space complexity, you can watch my videos or the design and analysis of the algorithm. Okay. In that playlist, I have explained how you can find the time and space complexity. Okay. Now to find the space complexity, we will take the help of the stack. So how many maximum number of function calls are there present on the stack? The total n plus 1 function calls. So basically space complexity will be order of n plus 1, right? And this is same as order of n. So the space complexity is order of n. This space is taken by the recursion. Okay. So yeah, this was all about this video. So there is another approach that you can use to find the sum of the first n natural number, and this is you can try by yourself. Okay, you can tell me in the solution of this thing in the comment box. Okay, so you have to actually write something here in the fill in the blanks. Okay, line number 1, what will come here, what will come here, and what will come here. Okay, if main function is called with 2 parameters, okay, 1 and n, and I want to find the natural number sum from 1 to n. Okay, so 2 parameters are being passed. Then how we can find the sum of first n natural number? Okay, so you can tell me in the comment box what will come in line 1, line 2, and line 3. Okay, so do like, share, comment this video, and please subscribe the channel and press the bell icon for the notification of the videos. Okay, so see you in the next video. Till then, goodbye.